Dr. Rick Whitman. I'm introducing Module 6 of your Perspectives in Natural Science class with this video. This video is all about chasing information, that we're naturally drawn to ask questions. Here I am in a job I had a few years ago where I am using a water bottle, you see here, and behind my arm there are two large cutouts because there's a handle where you'd pick up this water jar. I was using the water jar as a stand-in mannequin for testing the penetration of radiation into the cargo container behind me. It's aboard a tractor trailer body here. And what we found out was, or the question was, if you had stowaways inside a cargo container, would they, or people being smuggled, would they suffer from the radiation exposure that we use to scan cargo containers, X-ray and or gamma ray radiation? And the answer is, by testing, we were able to prove the point. Now today, due to the beauty of the internet, or the connectivity of the internet, we're able to see these high definition pictures of the Earth from space. Here's actually, this is a video. I started it with as just a still picture, but the amount of information you can get from this is fantastic. Here I'll show you another one too. This is a program called Earth Null School, and from it you can look at real-time images of a variety of information over all over the world right now. I'll give you a couple of examples. Using real-time satellite data from around the world, a gentleman in Japan figured out how to amalgamate it so it shows real-time, and what you're looking at here is a temperature scale all over the world, and the warmer the colors, for example this reddish color here you see over South America or over Africa, denotes a warm temperature, whereas the blues that you see here in the upper northern hemisphere show colder temperatures. We can even zoom in further. We can come into, for example, perhaps the greater Chicago area. The weather right there, right now, comes up, and I'll slide this over. You can see what I'm seeing. It says that right now at that location, which is 41 degrees, 0.68 north, and 88 degrees, 3 minutes west, roughly Chicago. This is the speed of the wind, how fast the wind's going, and oh, by the way, I can change these to meters per second, or even knots if I'm into that, or miles per hour, and I can change this to 56 degrees, which is the current temperature in Chicago. Down here in the Yucatan Peninsula, however, it's 99 degrees, or near Disney World right now, it's 82 degrees. You get the idea. Up in central Maine, I'm looking at 40 degrees. Perhaps the greater Seattle area. I'm going to stay close to the lake, to the bay here. 50 degrees. And down in the greater Los Angeles area, 51 degrees as well. You can also see where there's some wind gradients happening. Kind of fun. There's some other things I can do too. I can change this so I can look at particulates around the world. And now I'm looking at particulates with this grid, this color band here will give me an idea of what's going on. And I can look, for example, for sulfates, which are a side effect of burning coal frequently. Now, I've just switched the screen so you're looking at sulfur dioxide in particular. And you can see where these tell you where the coal-fired power plants are, including a very large couple of them up in Canada, which is kind of fascinating. You can also measure what the particulate rate is, and I'll look at one of the darker ones here, and I'm getting 15 micrograms per cubic meter. Let's look at this big one up in Canada. This is Calgary, and it gives me 31 micrograms, which is not unsubstantial. You can tell by the dark color here, this is in different areas of China proper, 160 here, 462 there. So you can tell, you can even do real-time research. These are the big cities in India, 274 on that one, and more. Even in Saudi Arabia, which you wouldn't think would have coal-fired power plants, they're building their first nuclear plant right now. Well, enough of that. Let's get on today's lesson and get you started. This gives you a quick look at what we've got going this week. There's only 2 assignments you have to do: a short answer, why ask why, and research in science. Kind of interesting. When asking why, just as the radiation scanning of cargo containers I was telling you about earlier that I did, it starts with a question. We are naturally curious. Science helps us find good answers. And in the shaping of your questions, where do our questions lead us? As you read your current articles, you should be looking for secondary articles by this point in the Shapiro Library, and you want to look for a PDF whenever you can, because without a PDF you only get plain text. You don't get any maps, charts, or other figures or diagrams that would help you understand a topic, especially in science. So here you've got an article, that the 10 big questions in science, done by The Guardian, a British publication a couple years ago. Kind of fascinating. By the way, if one of these pops up with an ad video, ignore it and just go past it. We didn't plan that. What's the universe made of? How life began? Are we alone in the universe? What makes us human? Going to college, I hope. What is consciousness? And so on. There's a lot of very good questions here. I think you'll enjoy these, and so you want to explore these as best you can. After your 20 big questions in science, you'll find there's 10 questions that were posed to Stephen Hawking. Kind of a fascinating guy. Unfortunately, he's just passed away recently, but he is easily one of the giants of our time. He's as important to folks under 50 as Einstein was to folks a generation or 2 ago. Continuing, you're then going to have an activity here where you're going to look at you're going to hopefully learn to recognize, I think most of you do already, how scientific developments inform scientific questions. Now, there's not a big stretch in our modern time between science and what the ancients would have called magic. Things happen because of the applied science, things that make science applicable to everyday life, the magic of the telephone, and even the ability to navigate using a cell telephone that has more computing power than the 12 computers aboard the space shuttle that my brother-in-law used to work for. Fascinating. And the next part of your module this week involves this short answer: why ask why. Now, based on the video that you just watched, answer the following questions. And there's 3 questions. You should have a separate paragraph for each. Now, because your name is on the paper, I really want to stress how important it is that you use the word I or me as sparingly as possible. You could say, for example, after reviewing the Stephen Hawking video, it seems, and start from there. Of course, you're the one doing the it seems. Your name is on the paper. How has Hawking's research contributed to the field of natural science? You may have to do a little side work to answer that one. In reviewing Hawking's research, comma, he has made major contributions in these areas, A, B, and C, period. Now, paragraphs usually have 2 sentences, so don't just do 1 sentence and walk away. The last thing you want to do is, for your 3rd sentence, is when you consider the work of natural scientists in general, how do you think developments in scientific thinking end up influencing how scientific study is carried out? Provide an example. Now, once again, you want to say, at the conclusion of this module, it would seem, it appears, that scientific thinking influences study in this way. And then use an example. Again, 2 sentences per paragraph. I dare you to see if you can do this without using the word I. It's a challenge. You also want to limit how often you use the words is or are, and in fact all of these words, be, am, is, are, was, were, being, and been. They'll allow you to be more direct, more concise, more to the point, and you won't lose your reader. In this case, me. Oh, and before I leave this portion, I should point out to you that this short answer rubric, which you can pull up, shows you how your instructor, in this case me, or any instructor in any class you have, is grading your work. So it's for the why ask why. To get the most points, you discussed what drove a scientist like Hawking to ask why. Lots of ways you can answer that, but if you don't answer why ask why, how can you get any points at all? And you get 30% of the total points on this assignment. Contribution, influence, and communicating clearly. Communicating clearly, by the way, is where you can gain or lose depending on how clear your writing is. But if your writing is awful, you can't make this first block. You'll end up being in the second or third. So this is why you want to review these rubrics so you know what your teachers, in this case me, are looking at for your work. In the next part, you're going to look at what drives scientific exploration. Now, there's some material here. This guy Kirk Johnson, by the way, who was on a long video on the history of North America, fascinating guy. And this article on Ebola vaccine research would remind you a lot of the current measles and mumps anti-vaccine backlash that's happening, especially out in Oregon now. So this is kind of a timely thing to be thinking about, especially because there's been a recent outbreak in Ebola in Africa, which is the nightmare disease we hope we never see here. And the whole idea here is you ought to be able to ask yourself when you're done, did I relate scientific developments to factors that motivate scientists to continue researching? It's worth thinking about. And the final part of this lesson involves taking a quiz worth 20 points. You get to take this more than once, and it's worth your while because it'll help. Your highest score counts anyway, so you might as well look at what the test bank has and make the most of it. Now, keep looking back at your article. If you've not pulled down a secondary or tertiary article to support your work with your original news article, by now you should be doing that. You're in college now. It's not, with being an adult comes adult responsibilities, and you shouldn't be waiting to be spoon-fed, but rather go out and prepare your own table. That's all I have for now. Do send me an email if you have comments, or if you like this video, by the way. Thank you.